All right, class, let's take a look at a quick video on how to find domain of composition of functions. All right, so there are three main steps. The first step is to find the domain of the inner function, the one inside of the parentheses. Then we need to find what the composite function is by using the rules. And then step 3 is to find the domain of that composite function. We compare the two domains, we see what numbers are valid that work for the function. All right, let's take a look at our first example. Okay, this one is f of x and g of x. We have 7 over 1 minus 2x and then 1 over x. All right, so we need to find the composition of f and g. And we can rewrite it like this, where g of x is our inner function. All right, so that means we first need to look at what this inner function's domain is. All right, so the domain, we take the denominator, and we know that the denominator cannot equal 0, because if it did, we would be dividing by 0 and it would be undefined. So we simply take this denominator x, and we know that it cannot be 0 for the domain. So every other number but 0 will work for g of x. All right, now we find our composition. To do that, we're going to put g of x in here. It's 1 over x. And then we go to our other function, f, and put 1 over x in for x up here. So that looks like 7 divided by 1 minus 2 times, plug in the 1 over x. So then we simplify this a little bit. That's 7 divided by 1 minus, well, that'd be 2 divided by x. Okay, now we can multiply everything by x in order to cancel out this little fraction. So that would leave us then 7x divided by x minus 2. All right, now let's figure out what the domain is for this. Okay, so again, we have a denominator, so we know the denominator could not equal 0. So add 2 to both sides, we know x could not equal 2. All right, so we have two things. X cannot be 0. X cannot be 2. All right, so we need to think about every other number but 0 and 2. So our entire domain would start at negative infinity. The smaller number is 0, so it goes up to 0. Then it goes from 0 over to 2, which is our next number here. And then from 2 to infinity. So there's how you find the domain of a fraction like this. All right. So next, let's take a look at a square root problem. I have one here for us from the homework. All right, so here's f of x and g of x. Again, let's find this composition. Okay, so I'm going to use do the same one, where the inner function is g of x. All right, so here we do not have any, let's see, denominators or fractions, and we do not have a square root here for g of x. So the domain would be all real numbers. Every number we plug in will work and be valid with the function g of x. Now, finding the composition, we're going to take this x squared minus 5, plug it in to f. So that looks like this. F is a square root. We're going to plug in x squared minus 5 right up here for the x. So that all is there, plus 5 afterwards. Now simplify it. We really don't need these parentheses. We can cancel out the 5s. Then we have the square root of x squared. And the square root and the squared cancel out and give us an absolute value of x. Okay, so this is the domain for this one. This is a composition, rather, for this one. Now, the domain, we can plug in any value of x and still get an answer. So, like the absolute value of -2 is 2, the absolute value of 5 is 5, so on. So, the domain would be -infinity to infinity for this composition. So, we combine the two domains, everything works. So, the total domain would be -infinity to infinity for this composition. All right, maybe we want to look at this one again, but take a look at the opposite composition where we plug in, let's see, G composed with F. Okay, so that means that we're going to plug in f of x into G. All right, so f of x is a square root, and we're going to plug that into G. Okay, so there's G up here, the square root goes in up there, so that would be the square root of x plus 5 squared, the squared's from up there, minus 5. All right, so the square root and the squared cancel out. We have x plus 5 minus 5. 5's cancel out. That is just equal to x. Our domain for this x is just -infinity to infinity. Every number works. But, again, we need to look at our inner function. Inner function's f now. What is the domain of this? Well, the domain of the square root of x plus 5, we know that it has to be greater than or equal to 0 for any square root to work. In other words, we can't have any negative numbers underneath the square root when we add 5 to them. So we subtract 5 from both sides. X is greater than or equal to 5. So that restricts our domain. It can no longer be -infinity to infinity. We have a restriction. X is greater than 5. So our new domain would be all numbers, including 5 and greater. So that would be the answer for the composition functions domain. All right, I hope that helps out with the domain and composition functions. Keep trying these problems. I think you'll get it.